Hello friends, I am very happy to see you again. Welcome to our video on the birth and death of stars. Throughout history, humans have been fascinated by the stars above us. From ancient myths to modern-day science, stars have played a significant role in shaping our understanding of the universe. Do you love to see stars at night? Have you ever stared at the sky and wondered how the stars were born? Stars are some of the most fascinating celestial objects in the universe. They come in all shapes, sizes, and colors and play a crucial role in the formation of galaxies. However, they are not immortal and have a finite lifespan, eventually coming to an end in one of several ways. In this video, we will explore the birth and death of stars and the different stages of their life cycles. We will discuss the various types of stars, from red dwarfs to blue giants, and examine the forces that govern their behavior, such as gravity and nuclear fusion. We will also look at the different ways in which stars die, including supernovae and black holes. Finally, we will consider the impact that stars have on the universe around them and their role in creating the building blocks of life. Do you remember we must have asked someone as children how the stars are born and blink? I have the answer for you. No, for the delay, let's start with several steps of the birth and death of stars. Number 1 is star formation. Stars are formed from massive clouds of gas and dust called nebulae. These clouds are made up mainly of hydrogen and helium, which are the most common elements in the universe. As time passes, the gravitational forces acting on the nebulae cause them to shrink and collapse, forming a dense core. This core then becomes the protostar, which begins to grow and heat up as it pulls in more gas and dust. As the temperature at the core of the protostar reaches millions of degrees, nuclear fusion starts to occur, and the protostar transforms into a fully fledged star. This process is how stars are born and is essential for the creation of the universe we know today. Stars play a vital role in producing the heavy elements that make up planets and living beings, and they also emit light and energy that allow life to thrive on planets in their vicinity. Number 2 is stellar evolution. The evolution of a star is influenced by its mass. The more massive the star, the faster it consumes its fuel, leading to a shorter lifespan. Our Sun, with a mass of around 1 solar mass, is expected to last for approximately 10 billion years. Throughout most of its life, a star like our Sun will be burning hydrogen in its core, producing helium through nuclear fusion. As the star's hydrogen fuel is consumed, the core contracts and the outer layers of the star expand and cool. This process causes the star to evolve into a red giant, which will remain for the rest of its life. During this phase, the star's core continues to contract, and helium is fused into heavier elements. The outer layers of the star are ejected into space, forming a planetary nebula. The remaining core of the star, known as a white dwarf, will gradually cool and fade away over billions of years. For more massive stars, the evolution process is more rapid and intense. They may evolve into different types of stars, such as supergiants, neutron stars, or even black holes, depending on their mass and other factors. The study of stellar evolution helps us understand the origins of the universe and the various celestial bodies that inhabit it. Number 3 is supernovae. When a star has consumed all of its nuclear fuel, it can no longer generate enough energy to counteract the force of gravity pulling it inward. This causes the core of the star to collapse in on itself, leading to a catastrophic explosion called a supernova. Supernovae release an immense amount of energy, producing heavier elements like iron, nickel, and gold, which are then dispersed throughout the universe. The explosion can be so bright that it can briefly outshine an entire galaxy, making it one of the most powerful events in the universe. Supernovae can occur in different ways, depending on the mass of the star. For lower mass stars, the collapse of the core can lead to a Type 1 supernova, while more massive stars undergo a Type 2 supernova. Type 2 supernovae are much more energetic, as they involve the collapse of the core followed by a massive explosion caused by the rebound of the core. Supernovae play an important role in the evolution of the universe, as they are responsible for producing and distributing heavy elements that are essential for the formation of new stars and planets. They also provide a unique opportunity for scientists to study the extreme physics of these events and learn more about the fundamental properties of the universe. Number 4 is neutron stars and black holes. When a massive star undergoes a supernova, the core of the star can collapse to form either a neutron star or a black hole. A neutron star is an incredibly dense object with a mass greater than that of the Sun, but compressed into a sphere only a few miles in diameter. Neutron stars are composed almost entirely of neutrons and are so dense that a teaspoon of their material would weigh billions of tons on Earth. Black holes, on the other hand, are even more extreme. They form when the core of a massive star collapses to a point of infinite density and zero volume, known as a singularity. The gravitational pull of a black hole is so strong that it can prevent anything, not even light, from escaping its grasp, making it invisible to telescopes. Despite their differences, both neutron stars and black holes are fascinating objects that challenge our understanding of the universe. They have unique properties that can be used to study extreme physics, such as the effects of gravity on space-time and the behavior of matter under extreme conditions. The study of neutron stars and black holes has also led to discoveries in fields such as astronomy and astrophysics, allowing us to gain a deeper understanding of the nature of the universe and the objects that inhabit it. At last, let's see cosmic recycling, the creation of new stars and planets. The process of cosmic recycling begins with the death of a star. When a star runs out of fuel, it collapses under its gravity and explodes in a supernova. This explosion releases a massive amount of energy and materials into space. The materials from the explosion are then recycled and used to create new stars and planets. As the materials from the supernova expand and cool, they begin to clump together due to gravity. Over time, these clumps become denser and hotter, eventually forming a protostar. The protostar continues to grow and accumulate more materials until it becomes a full-fledged star. While the protostar is forming, the leftover materials from the supernova begin to form disks around the new star. These disks are made up of gas and dust and can eventually coalesce into planets. This is how rocky planets like Earth are formed. The gas giants like Jupiter are formed further away from the star, where the materials are cooler and can accumulate more easily. The process of cosmic recycling doesn't stop there. When stars reach the end of their lives, they too will explode in a supernova and release more materials into space. These materials will then be recycled to form new stars and planets, continuing the cycle of cosmic recycling. It's important to note that the process of cosmic recycling is not only responsible for the creation of new stars and planets, but also for the diversity of materials in the universe. The materials created in one supernova can differ from those created in another, leading to a variety of materials that can be used to form new celestial bodies. The life cycle of stars is a complex and fascinating subject. From their formation in massive nebulae to their eventual deaths as supernovae or collapsing into black holes, stars are a critical component of the universe. We hope you have learned something new about these fascinating celestial objects and their life cycles. Stars are truly one of the most awe-inspiring wonders of the universe, and their impact on the world around us cannot be overstated. From creating the building blocks of life to helping us navigate our way through the night sky, stars are an integral part of our existence. Thank you for watching our video on the birth and death of stars. If you found this video informative, please like and subscribe to our channel for more content like this.